So just as we ended with a section on finding the sample size needed to attain a certain margin of error with proportions, let's do the same thing with means. Problem here though is the margin of error is going to be equal to t-crit, which is dependent upon the sample size, s, which is a measure from the sample, and n, which is what we want to solve. So this depends on n, this is n. We want both those and don't have either. And you won't have this unless you take a sample, unless you've already collected the sample, which you can't do if you don't know sample size. So we're in quite the bind here. All three of these things are unknown. So how do we tackle this? Well, first, we must have an estimate for S. Use a pilot study, use historical data, no getting around that. The issue with t-crit can be handled two ways. We have kind of the AP way, which I'm going to call method 1, how I'm going to ask you to do it in this class, and then kind of a extra method if you're interested. If you don't monkey around with this if you don't want to, guys. Just forget it even exists. This is how we're going to do it in this class. Counselor wants to estimate the average number of texts sent by students at his or her school. He wants, or I guess her school, he wants to estimate mu at 95% confidence with a margin of error of at most 2 texts. So he wants his margin of error to be less than or equal to 2 texts. A similar study at a nearby high school discovered that the number of texts sent during school hours had a standard deviation of about 5. So yeah, right. But that's the historical or the pilot study, or I guess you're looking at a neighboring school. So we're going to use this. The AP way is to just forget about the t-crit and pretend you have Z. I guess if we shouldn't assume that we have the sigma because this is not our sigma, but we're pretending we have a sigma. This is just another hand-waving way to do things. Let's just pretend we have a Z to make it easier. Okay? It's not a good policy because when we do our Z, it's going to give us a sample size less than we need for T. So it's the opposite of conservative. It's a risky approach. But that's what we do. So pretend it's a Z. So the Z crit times sigma over square root of n. Now it becomes pretty easy, I guess. 1.96 times 5 over square root of n has got to be less than or equal to 2. And just solve this with the calculator. Or you can solve it by hand, but I just do it with the calculator, make it easy. 1.96 times square root of, was it 5? Over square root of n. What? That has got to be less than or equal to 2. If you just say it equals 2, it's going to give you the cutoff. That's fine too. So 24.01. Got to be greater than or equal to 24.01. Really close to 24, but we got to sample 25 or more. 25 kids or more. But like I said, because we used a Z, we're probably going to need more than 25 kids. And if this was a bad estimate, depending on which way it was bad, we might even need more than that. But that's how we do it on AP. It's fine. Good enough. Method 2 is to actually use that t-crit. T-crit times sigma over square root of n less than or equal to 2. We calculate that t-crit by using a t-inverse, where you put in the left area, 0.975, and then the degrees of freedom is n minus 1. So we could actually put in this function into the calculator, and then put in our margin of error, standard deviation, square root of n, we can attempt to see if the calculator's got the ability to solve this for n. And you're going to see that it doesn't quite, but kind of does. Actually, we just select this up here. Instead of putting in the 1.96, you can put in t inverse. Or why is it not recognizing it? Is it inverse t? Inverse t 0.975 comma n minus 1 degrees of freedom. Now if I hit enter, it does something, but that's craziness. I don't know what that is. It just has problems because it's a inequality. Gives us a domain error. When it tries to solve something numerically, it starts at, I don't know, maybe it starts at 0 or negatives. Well, you can't use the inverse t function with like negative or 0 degrees of freedom. So to get around that, you just need to put in an initial guess. So for n, just put in an initial guess. I'm going to say I think n is a sample size of 100. As long as it's a significantly large value, I think we're going to be okay here. So it's pretty impressive that it does. You have to do a little bit of finagling, but it does it. 26.4, 26.5. So we need to sample 27 kids or more. And you can see that, a couple more kids than what, that's the difference between the z-crit and the t-crit. In reality, you should probably do 30 or more. I mean, because you might have issues with your standard deviation as well. But please don't worry about this. Don't worry about this crazy thing here. You don't have to do any of that. You are responsible for just pretending it's a z and using this value. This value needs to be given to you though, okay? That concludes chapter 8. Good luck.